Ashish sir for start your session.
Okay, sir. Thanks a lot, sir.
Thank you, sir.
Okay. So today, in the last session of this workshop, we have studied about stereolithography, that is STL. That was just one process, one way to print your objects in 3D from 3D models. So apart from that, we have so many techniques are there. You can say processes are there, methodologies are there to print our objects in 3D, and that from the 3D different materials and 3D different models and all. So we will see some of them and how they are categorized and what we have to learn. So in this session, the outline of this session will be 3D object creation. Then we will study about 3D printing processes, type of 3D printing processes, how many we have. So we have 7 different type of 3D printing processes. So we will learn about them. Then we will learn about something disadvantages and advantages of 3D printing process of each of them. What are the advantages? What are the disadvantages of them? And then we will what the material we can use with those 3D printing processes. Some of them are just same method, but difference from one another just because of the material used in that. So we will learn about that also. Then at last, I will try to give you some overviews of 3D softwares. Most of the 3D softwares are basically proprietary software, so we have to purchase license of them. So and very few are there in open source domain, so you can just download and use. And in the last lecture session itself, I have shown you free CAD, so that was there. So today I will try to provide you the overview of Tinder CAD also. And then a SketchUp is also there, but that is Google's proprietary software. So we will see that part also a little bit. And so what you will learn from this session? So you will learn from this session that you will be able to explain various 3D printing processes. You can easily differentiate 3D printing processes from one another. And then you will be able to choose the 3D printing material according to the process. And again, I'm saying I am not giving you the criteria or the way to judge about the printers, but if you know 3D printing processes and if you know the material you are going to use, definitely it will help you to choose your printers, 3D printing printers, basically 3D printers. So that will help you. And also you can able to choose your 3D printing software also, because software is very important part of 3D printing. Without software you can't model, and if you will not model, then you will not generate that printable files of that software and all. So it's needed, very much needed part of that process, complete process. So we will learn about these things today. And give me 1 minute. And what is 3D object creation? So it is not that it started from 1986. 3D objects creation was already with human beings, but manually. What I think all of you have seen someone who carved a stone or someone who carved wood. In Tamil Nadu, we have very much famous place there. They basically carved the wood with that hammer and their different small, you can say, tools, and they will bring that idol from the wood itself. So and that part is there. So we used to do that. We have lots of idols in our temples. So those especially are carved. So that concept is subtractive manufacturing. Subtractive manufacturing, when you will remove, see, I need this. Give me 1 minute. So I need this spare. So what I am doing with this, I am taking one big cube and carving, means removing the extra parts from that, and at last I will get this. So that is subtractive manufacturing. When you will remove materials from the stock, such as CNC machinings are there, machines are there. So that part is there. Then in 1986, we have started with additive manufacturing. Additive manufacturing is, we have to generate a spare. So what you will do, I will generate the bottom, very bottom thin line, then upper thin line, then upper thin line. So like this. So we are putting this on one layer upon one layer. So we are adding material of layers in different manner. So at last we will get this. Okay, so that's the way of additive manufacturing. So 3D object creations are already there. Okay, then we have included computers in that, and then now we are going. So adding and subtracting materials often in sequential layer under human or computer control to create a 3D object. So that is 3D object creations. Okay, now what we are doing, we are going to print. So we are learning about 3D object printing, and that printing comes under additive manufacturing, AM, you can say. So for printing, what you will do, we have to add, we can't remove the materials from the stock. That is not 3D printing. Okay, so 3D printing, in 3D printing, we have to add material in layer by layer manner. Okay, so we will see that part also. We are not learning about subtractive manufacturing, we are learning about additive manufacturing. So remember that part. And then came 3D printing processes. So 3D printing, or you can say additive manufacturing, okay, is construction of a three-dimensional object from CAD model or a digital 3D model. So when you are going to construct, not to remove, we have to add a layer by layer processes along with that CAD model, or in to convert CAD model in 3D objects, three-dimensional objects. So that is basically comes under 3D printing. Okay, but when you are saying that 3D printing term, so it is not just one process. It has different techniques, and you can use any of them according to your requirement. Okay, so how their different processes are there. So some of them will deposit, join, and then solidify under computer control and create 3D objects. Different type of materials can be used. Okay, and such as plastics, liquids are there, powder grains are there. Then last session I have told about filaments. So filaments are also there. So you can say material filaments are there, like aluminum, copper, so like that. So we have so many materials are there. So we use those materials and fused them together. On not different kind of materials can be fused. So you have to fuse same materials in one. Like if you are using plastic, then you have to use plastic itself and fused all the plastic and in layer by layer manner, and then you will generate one 3D object. So that comes under 3D printing. The 3D printing processes are there. So we will learn about those processes further. Okay, what's happening because you can say the key difference in those technologies are at some places, means they maybe some of the techniques are different upon the materials they are going to use. Some of the techniques are different upon the lasers that they are going to give the heat to melt down the material at a particular temperature. So that part is there. Some of the techniques are different in basically the complete working principle of them. Okay, you can't heat and then generate a particular temperature to melt down the material and be collect or combine together. You have to paste. So we have pasting methods also. So one layer is pasted upon the another and then pressed hard to generate. That was basically used in the making of plywoods. You have seen that boards and plywoods. So what the machine will do? So it will give you one thin paper, and then on the thin paper itself they will paste another thin paper, and then they will provide huge pressure on that at a particular temperature. Then all the paper will be joined together. So in Sanmaika we used to generate this type of things, this process. So some of the different type of physical transformation which are used in 3D printing includes melt extrusions, and then light polymerization, then continuous liquid interface, and then these we will learn how they are different from each another, and how one process is there and another process is different. So, and remember, all the processes and piece of equipment has their own pros and cons associated with it. So you have to judge. If you have knowledge of all the processes, then you have to judge which process is going to be more accurately fit in your own 3D printing or 3D manufacturing, or you can say 3D printing objects creation and all. So see, I'm going to I'm going to generate one ideal of plastic. So I should not use aluminum filament in that, and that process is not needed for me. Okay, so like that we should go with the process which has plastic melting and polymer melting concept. So we have that. We will see that part, which have which option, which material is used in which type of process. So we will see that part. So upon depends upon the pros and cons, you can judge and you can find out your own process needed to be get 3D objects printed. So usually these evolves aspects such as speed of the printing machines, okay, and how rapidly you want to generate your 3D object. So like very fast rapid prototyping we already have studied, we have already have discussed in last session that stereolithography is there. Okay, then cost is also involved, versatility is also there. Then respect to feedstock material. Feedstock material is basically the filament or the material you are going to feed in the printer. That's known as feedstock material. Then geometrical limitation is also there, because in the last itself we have seen then you have to generate CAD model, then you have to convert that CAD model in STL files, and then you have to slice that STL files model, or you can say STL model, you have to slice. So each and every model you are going to generate is have some their own geometrical limitations. So you have to go with those you have to consider those geometrical limitations also. And then at last you can say the tolerance of that. Give me 1 minute. Sorry guys, got important call, that's why. Okay, so we'll start. So nowadays, you have seen or you have got the news about that some printers are large enough to fabricate building wish list. Other, okay, so some printers are large enough to fabricate even buildings. So you have seen in some US and UK has the printed that complete complete building itself printed with the 3D printers itself. So that part is there. So we will see how the processes are different from each other. The main difference between processes are the way the layer are deposited to create parts. Okay, and the second part, they are different. The material that can be used with that process. So two main differences are there in different kind of processes. So first one is how they are going to generate the layer, each one layer, how they are going to generate, and then how they are going to add the another layer upon that previous layer. That part is there. Then then the material that can be used with that to process that these two, on these 2 points, each and every process is different. So some methods you can say melt or soften the melt the material to produce the layer. Okay, for example, selective laser melting is there, SLM, or you can say direct metal laser stringing is there. So these are some those who will melt the laser. Okay, but some those who will create or harden the liquid itself, means the material is in liquid form. Okay, and then they create the cure, or you can say the hard, they make the liquid hardened part. So it convert liquid into solid, and the previous one some process are converting or melting solid to liquid, a little liquid, not exact liquid. So that the concept. So both are different. So SLA is different, and then you can say the previous one FFF, SSL, SLM, so FDM. These are different. So here itself I have given you two ways. So the layer they are going to create, both have different way. Okay. So and if you will go with LOM, that thin layers are cut to shape and join together. So LOM is also there. So how they will do, what they will do, they will cut either paper or polymer sheets or metal sheets, and then they will generate a single layer of that, and then they will put that single layer on the top of previous layer, then top of previous layer, then top of previous layer, and then they will generate the complete 3D model or 3D objects. So laminated object manufacturing is also there. So we will see that part also. Then we have inkjet technology is also there. So particle deposition using inkjet technology. So how they will do, they will drop they will provide drop by drop, means how to say that, the complete material is here known as ink. Okay, the solid ink from the hot melted material, means they will take material, they will melt it little bit, and that material will melted material will be used as ink. Okay, and then they will drop that melted material on single points wherever there is needed. And in this there is very much good concept that you can use color can be used. So colored 3D models can be 3D models can be produced with this particle deposition inkjet techniques. So this one is very much uses. So each method has its own advantage and drawbacks. So we will We will see that part also. Now what? These are basically the difference between printers, how one printer is different. So printer basically depends upon the process, and because when I'm talking about the process concept, it is completely associated with the printer, because the way printer is going to use to create that 3D model is known as process. I'm not talking about the modeling process, modeling of 3D models. I'm talking about the 3D creations, 3D generation, 3D object generations part. Okay, so remember that. That's why. So that's why it is written on this slide that every printer is different from each other. Some uses the powder of the material, and some uses the liquid form of that material. Some uses that little bit filament type of material. So when you are going to choose a machine for your printing process, so you should generally think about that speed of that printing, and then how much upon how much temperature it can work. Temperature will be also there. Then the process it's going to use to generate the you can say complete 3D objects. So process is also very much useful and needed. So remember that part also. So there are lots of printing process techniques are there, but all of them can be subclassified. You can say in these 7 different process or techniques. Okay, so can be grouped into 7 categories, you can say. So from starting from 1970s, several training processes have been invented. Okay, but all of them can be, you can say these 7 categories, they can be classified. So we will see these 7 categories and some of those techniques which comes under these categories. So very first one is wet photopolymerization. So we will see that how it's going to be do and what are the advantage and disadvantage of ones. So it was invented, or you can say patented, in 1986 by Chuck Hull. Remember the name? In the last session, I have already told you that SLA. SLA was patented by Chuck Hull. The same SLA, you can say, is just comes under wet photopolymerization. Okay, category. Okay, so we have more different techniques are also there, but they are just little bit different from SLA, or you can say STL. Okay, so we have, that's why we have combined it, both of them in one category, and that category is known as wet photopolymerization. So in this process, a vat of liquid polymer, a vat means a vessel, or you can say a tub or something like some kind of container which holds the liquid polymer. So that is vat. So in this process, a vat of liquid polymer is exposed to control laser, or you can say digital light projector. Both are different, laser and digital light projector. So under safe light conditions, why? When you will expose liquid polymer to laser or digital light projector, it will make that particular part of that polymer to be hardened, and through cross-linking driven by adding reactions of carbon double bond. Okay, and then polymer will be hardened. Okay, that's the concept, and that reaction and that process is known as polymerization. So polymerization occurs when photopolymer or photosynthesis polymer are exposed to light. Okay, then what will happen? Then photopolymer basically contains chromophores, and that chromophores, Okay, molecules, the molecules of those chromophores will be you can say bound or double bound and made in acrylites to generate basically hard polymers. Okay, and that's the complete process you are going to use in this technique. So wet photopolymerization is, you have vessel of liquid polymers. In that you will provide light, or either with a laser, or that can be digital light projector is also there, so you can use those, any of them. Okay, and then what it will happen, it will do, or you can say in easy term you can do, it will harden the liquid polymer at some parts, and then and then you will get your own 3D objects. And at last what will be happen, we will drain out the liquid, or you can remove that hardened part of polymer from that liquid itself. So two things are there: either you can drain the wet and leaving the solid material inside that, or you can pick out, or you can say take out that hardened solid model. So this is the complete way of wet photopolymerization. Okay, and in that you can say SLT, stereo, not my mistake. It should be not SLT. It should be STL. My mistake. It is wrongly written here. Let me correct it now. It's further I will forget. Okay, so an example is STL, stereolithography, and CLIP, continuous liquid interface production. So two different techniques are there that comes under wet photopolymerization. So the same image from tomorrow's session, here we are using laser, and that comes under STL, okay, stereolithography. So the laser will come, and this is wet. This complete portion is, you can say, wet. Okay, so this complete portion is wet, and inside it we have liquid polymer, and we are providing laser beam, and that laser beam is going to be react with this liquid polymer and harden. So how is this going to be happen? We have written here this part. Okay, so liquid polymer reacts with the light. Again, because that's why we have told it's polymer, photosensitive polymers. Okay, and that it, because photopolymers contains chromophores, that chromophores react with the light and then make it harden, and you can say harden, in technical terms you can say carbon-carbon double bond. So it's make it carbon-carbon double bonds in acrylites form. Okay, and that form will be given to you guys. So and this complete process is known as polymerization, the complete process. Okay, and that's the way we create one single layer, and again that layer will again that layer means the very thin first line will create it on the top itself, and then this base, or you can say platform, will come down, little bit down, and then the second layer will create, then the little bit down the third layer, that little bit down, then fourth layer, and that's why at this many layers will be created, and at last you will get. So when the process starts, this platform will be on top, very top of the here, something like here. Okay, and when the first layer will be created, it's come very in millimeters, you can say it's come nearly here, and then third layer, then it will come, and after some time it will come at bottom. Okay, when that height will be decided and that complete process happens. So this image is from STL. Okay, when you will change this laser, you will discard this laser and use digital light projector here. it will known as clip, continuous liquid interface productions. Okay, so when you are using laser, it comes under STL. When you will remove this laser and use digital photo, continuous photo projector, so that will be known as clip. So I have explained both parts, and that, listen, one layer can be minimum of 0.0000001 inch, okay, and up to this much weight will be there, only one. So think how much layers you have to create and how much the slicer has to slice the complete object. So in this one clip, so previous one is STL, and this in this clip use digital light processing, or you can say digital light projector instead of laser. Okay, and the rest of the process will be the same. Okay, so and because you are using digital light processing or digital light to harden that liquid polymer, so definitely you should use ultraviolet light at the bottom part of the pool. Bottom is transparent to ultraviolet light. It should be transparent to ultraviolet light. Then only that light will come out of that window, and then the object can be created. Okay, so this is the part. DLP and D2 oxygens. Okay, so that's why I already have explained the clip part also. So the clip is there. So, and what are the advantages of wet polymerization process? So in both cases, it is simple method to represent 3D models, or you do create 3D models, and then flexibility for more triangles will provide you more resolutions, better resolutions, because in both you have to go with models, and that modeling will give you. And easy to handle and transfer, so is concept in there. Large size, in this, that large size is there, so you can't compare to large CAD files will be produced, and no typical ordering, because no color can be used in this. Single one color of the liquid polymer will be used. Okay, so you can't use multiple color in this wet, and that you can go with different colors. So it is not possible. And then it's Dutch company, Lux Excel is there, which has commercialized this technology and printing platform after the patent of Chuck Hall completed in 2002 or 2001 maybe. So when the patent was the duration of patent was completed, then yes, Dutch company Lux Excel has provided different type of printers in this technology. So this is one very big company, and that company has lots of printers for 3D printing and all. So you can use, and you can contact them for if you require any printer, which especially depends upon wet photo polymerizations. Then another process or another category of process is known as material jetting. So what is material jetting? So material jetting, you can say it's something kind of inkjet printer, which we are using for our normal paper printing and all. So we used to provide a document printing, so that we have inkjet printer. Laser printer are already there, but I'm not saying that part. I'm using inkjet printers way. So in this material is jetted onto a build platform using either a continuous or drop on demand approach. Okay, so how that will do, one platform will be there, on that platform, the material will be jetted, means the material will be given drop by drop wherever it's needed approach. Okay, and then the one layer, and then the one layer will be created, and then the further the platform will go down, and the another layer will be created on that, on the top of that previous layer. So so material, we have some nozzle here. So we have, this is the platform, okay, where we are going to create. Okay, so this is elevator because it's go down by down, down by down. So, and then here we have you can say nozzles. These are nozzles, computer operated nozzles, and that we have two tub of that inks which have materials are there, and that material will come on this nozzle and that melted, and then thank you. So
आशीष सर आवाज नहीं आ रही है।
सर अब आ रही है?
हाँ आ रही है सर, आ रही है। ओके सर।
ओके, बाय मिस्टेक पता नहीं कैसे म्यूट हो गया। कोई बताएगा मुझे कहां तक मैंने एक्सप्लेन कर दिया था?
सर ये डायग्राम एक्सप्लेन करनी थी, ये हो गया था।
हाँ
नेक्स्ट
ये वाला,
हाँ ये एक्सप्लेन लगे थे आप करने, हाउ इट इज।
हाँ बस ये था सर।
हाँ
ये चल गया था ना यहाँ तक, बिकॉज मैंने आई थिंक अभी 2 ही पैराग्राफ एक्सप्लेन किया है, बिकॉज यहाँ से मैं स्किप करके यहाँ आ गया था बेसिकली, क्योंकि मैं आपको डिस्प्ले करना चाह रहा था कैसे हो रहा है।
हाँ यही है सर।
गुड गुड, थैंक यू सर, थैंक यू। सो लेट मी कंटिन्यू। सो ट्रेडिशनल इंकजेट प्रिंटर अगर आपको ध्यान हो तो उसमें एक बॉक्स होता था, उसमें इंक्स हुआ करती थी ब्लैक कलर की या फिर कलर वाली, और फिर हम क्या करते थे कि उस इंक को नोजल्स के हेल्प से जहां जहां जरूरत होती थी वहां प्रिंट करते थे। सेम प्रोसेस यहां भी है, सेम प्रोसेस यहां भी है। मेटल, अब मैं आपको फिर बताता हूं, ये जो पार्ट है, ये जो हम जिसको इंक बोल रहे हैं, ये बेसिकली क्या होगा कि आपका मटेरियल होगा आइदर इन लिक्विड फॉर्म और इन फिलामेंट। सम प्लेसेस में ये जो अभी यहाँ पे आपको बॉक्स के रूप में डिस्प्ले हो रहा है, दैट सॉरी माय मिस्टेक, आई स्टार्टेड इन हिंदी। That's the confidence you have when you are speaking in your mother tongue, that you will forget how and what you are speaking.
Okay. Sir, you can continue in the mother tongue. I think everyone understand the Hindi.
No. Alok sir has informed me some persons are also there from South India, and I have seen that Printo sir is there from Kerala, and that Sridharan sir is there also from Andhra. So we should go with English itself.
Okay.
Okay. So in this it can be of liquid, okay, and that will be come from the wires and or tubes, and then will be given through nodules to create one layer. Otherwise it can be of filament, and that filament will be given to it, and it is heated here and then dropped on that platform. So the build platform will be there. Then we have and in this plant, and then material jetting, you can use colored also. So this one is labeling. Once you will provide that liquid here complete on this surface, this labeling blade will come, and then it will label complete on that once throughout the surface. Okay, so that's the way you can say material jetting is working. Let's come here. Material is deposited from nozzle which moves horizontally across the complete build platforms. Okay, and there are it's vary from complexity and the controlling methods. We have different printing machines of material jettings, and we have drop on demand method. We have nanoparticle jettings. We have polyjet technology is there. Okay, so these three techniques are there, and those comes under the same process are used as material jetting. Okay, and then you can heat here. Some of them are providing, if liquid is there, material is in liquid form, there is no needed to heat it here. If it is in filament way, then the nozzle should have some heating process and little bit temperature just to melt down, not to break that material or not to too much melted. It will be on part.
First 2 years second years in year of admission first apply the date is scholarship date year first year apply
So different ways are there, and all are comes under material jetting. So polyjet use basically polymaterial in this technology. Nanoparticles jetting are used basically different type of materials like aluminum, cereals, and nanoparticles will be there, and then that will be jetted, you can say, in on the printer. So machines are different and materials are different, and then process is same, but if you will use poly materials, that will be comes under polyjet, and if you will nanoparticles, so it will comes under nanoparticle jetting. And this here drop on demand basically drop the material wherever it's needed, not on continuous process. So okay, so in material jetting process, we basically use polymers and plastics mostly, or you can say wax are also uses. So these many of polymers you can use polypropylene, HDPE, PS, PMMA, PC, ABS, then HIPS. You can use EDP also you can use. So these are basically different type of polymers. They have their own strength, okay, and they have their own melting temperatures and all. So you have to be careful about that. Okay. And but what I will say that if you will go with material jetting printers, or that comes under polyjet technology, so you can use any of them. Okay, any of them, because temperature control or that the temperature control can be done with the software part itself. Okay. So you should not think that if I'm using polypropylene, we need different printer. If I'm using PS or HDPE, so we need different printer. That is not needed, but the technology should be polyjet technology printer. So here the print head is positioned above the build platform. The print head, this is the print head, complete print head is there. So this print head will be positioned on the platform itself. Droplets of the machine materials are deposited from the print head. So this print head will drop the material on the surface required, and then either thermal or piezoelectric method. Okay, so either it is on already in liquid form, then it will drop by there. Otherwise, you have to melt it. If you are using filaments, you have to melt it from this nozzle and then drop it. Okay, then the complete process will take on this platform, and that platform will go little bit down after providing solidify of that material, and then it will go down, and then the further layer are built on the top of the previous layers, and like that you have generated. So material jetting basically is different process. Here we are basically not using laser, or you are not using light, a digital light, to solidify your polymers and all. So here UV curing lamp is already there, so that is just provide a little bit heat so that that complete layer will solidify. Okay. Now we have advantage and disadvantage of this material jetting. So basically the process benefits from high accuracy of depositions. Okay, so the means drop by drop. So wherever the drop is needed, that drop will come. Otherwise, no drop will there. So you will very low wastage happens in this. So you are not wasting any material in this. Whereas when you will go with wet polymerizations, so here those liquid which are not hardened, you have to drain it out, and that liquid is going to be not completely waste, but near about 80 to 70% will be go in wastage. But in material jetting, we are not wasting, so very low wastage process it is. And then in the same way, in the same process itself, allow multiple material parts and color under one process. So even if you are creating one single, you can say, object, in that object itself you can use multiple colors of same materials, or you can use different materials to create your own object. So like that facility is there in material jetting. So these are the advantages, but disadvantage, often support materials is required here. Support material will be required to create the boundaries, basically to create the boundaries, okay, or to cover the whole part. Wherever that is gap, wherever that is there, there is gap, so you have to fill that gap also with some support material, and that support material you can remove after the creation of complete 3D objects. Okay, and high accuracy can be achieved, but materials are limited. Again, I am saying only polymer and wax can be used. Only polymer and wax can be used, and polymers also can be this many, and plastics can be used in this. Okay, these are the disadvantages of and advantages of material jetting. Then we have binder jetting. So what is binder jetting? In binder jettings, we use some adhesive agents, okay, on top of the layers. On top of the layers. To bind one layer from the another one. Okay, and this method also known as inkjet 3D printing. Okay, and usually we need powder type of material in powder form. Okay, or you can say the material can be used as ceramics or metals can be used in this techniques. So in binder jet, we need some type of adhesive also. Okay, it is here. So how it's going to work? So there are two halves of single platform. So one half is known as build platforms, and second half is basically the material you have saved by which you are going to create. Okay, so in this, at starting of the process, it should be at same level. This platform and this platform on the same level. Okay. No, my mistake. Okay, so this layer, this build platform should be on top, and this powder supply platform on the bottom. And what will happen? This roller, this will filled with the powder of material, powder form of the material, and this roller will start from here and it will provide complete one layer to this build platforms. And from this adhesive liquid supply of adhesive, this will be dropped on a spatially on that particular points where you need to be generate another layer, and then this complete build platform will come very low part, smaller, get down, and then again the roller will come here and it will spread that powder form. So these points, this black dots, what I'm giving you here, so these black dots have adhesives. When you will roll the roller on that powder, that powder will only stuck on this adhesives. Okay, and then again it will go down upon that powder. This liquid adhesive will be again spreaded on the same position wherever needed. Again the roller will come and this process will happen when you will till the last when you will get that object. So here itself I have explained all these. Again it is inkjet, because here what we are using in as ink is liquid adhesive. Okay, so this is binder. Okay, binder of that material. So it depends upon the material you are going to use. The material which is in powder form, that material associated adhesive will be filled here. If you are using some give me 1 minute, I will okay, if you are using plastic, so plastic related plastic powder, then definitely you have to go with adhesive which are associated with plastic powder itself, and that will be ink jetted. So that's why it is inkjet technology. Inkjet printing head is there, so it will drop one adhesive everywhere. The process is completely different. Any doubt till now? So we will discuss, or shall I go ahead? Okay, we will go ahead. Again, the problem with this, you can say, due to the method of binding, material characteristic is not always suitable for a structural part. Okay, despite the relative speed and printing additional cost, additional post processing also is needed. You can't go with just that structural part itself. You have to go with pre-processing also, and that's adds significant time in the overall process. Okay, and this is also often referred as 3DP technology. 3DP means 3D printing technology. 3DP technology because it was copyrighted under this name. Binding jetter was copyrighted under this name, so it was also known as 3DP technology. What are the advantages and disadvantages of this? So part can be made with a range of different colors. Range of different colors can be used in this. Uses of range of materials also metal, polymer, and ceramic can be used in this. So all type of material can be used. But remember, the adhesive will be also used according to material itself. If you are using metal, then you have to go with the adhesive used in that particular metal. If you are going for polymer, so you can go with adhesive used in the polymer itself. Okay, the process is generally faster than others, but the problem is that it needs pre-processing. So post-processing also is there. So and pre-processing is also there. So the complete overall process takes time, but just to create or generate the model, it is very fast. And if you remember, we are using two different things. So one is powder and one is liquid adhesive. So lots of combinations can be created here. Okay, so that's one benefit. And not always suitable for a structural part due to the use of binder material. So what you are doing, you are adding, just for example, think that this is one, you can say, what to say, just think that this has some liquid Fevicol type things. So Fevicol is there, and then this is some powder of polymer, and then you are using that Fevicol to combine. So each layer, Fevicol is on each layer, remember, okay, and that can be broken. That can be broken because that is two objects binded to each other with the help of Fevicol, or you can say the liquid adhesive here. Okay, so it can be not that much benefited, or you can say appropriate for a structural object. Okay, it can break out on maybe on due to some causes because you are binded something. So that's the problem, and that's why it's not suitable for structural parts of any. Just think that you are printing car and you are creating some binded part of that car, and it's broke down at some level. So you should not use this technique there. Then also we have powder bed fusion. Powder bed fusion is, you can say, mostly used concept for 3D printing. So selective fusions of material on a particular bed is known as powder based bed. So what we are doing here, see, so this is the one bed which we are using here. This is powder which is there, and then we are fusing that. Here we are not using, remember, we are not using adhesive. We are fusing that powder and making it hard on some particular places. Okay, so the same concept which we have in binder jetting concept, but there is difference, huge difference, because in that we are using adhesive. Here we are not using adhesive, we are fusing. Give me 1 minute. Okay, now go ahead. So in this powder based fusion, what you have to do, the same concept, the powder will be here, the material powder will be here. Then we have the complete, you can say bed is there because this platform is there. So platform will be on top, the powder will be here. Once the powder will, you labeling, you can say the labeling motor will be here, and then the label motor will provide the powder, complete powder on this layer, on this bed. And then this fusion will, this nozzle, or you can say that this nozzle will fuse that particular powder on a area where we needed that. So in selective heating sintering, the problem, the same concept is there, but we have selective laser sintering, selective laser melting, electron beam melting. So all are different. Okay, and why they are different? They are different because of this nozzle itself. So in this nozzle, we have three different concepts. So one is using laser to sinter that material or powder, and one is to use laser to melt that powder and combine that powder in one, and then you can provide electron beam for melting also. So all are using same concept of powder bed fusion, but this nozzle is going to be different in each of them, and that nozzle is going to accordingly what the material you are going to use. Okay, so in laser sintering techniques includes selective laser sintering with both metals and polymers. So that many metals and polymers you can use: almonide, elastomer, you can use, and then these many will be with the help of laser sintering, you can combine their particles or their powders and then create your objects. But somewhere, some in different, you will need electron beam to melt down that powder and combine them at a particular point. So that is different way, and that's why these three techniques are different from each one, but all they use the very same printing way. So provide the powder on bed on this bed, okay, and then due to this nozzle, or you say laser beam, or you can say electron beam, will be provided on this and then melt this special part, or then make it hard or joint once again, and then create your complete object layer by layer. And then this one, after one layer, this F or this bed will come down and this will go up. So that's the way we are using in powder bed fusion. So it's here what I have explained about selective heat sintering. A thermal printer head, this is the thermal printer head, applies the heat to the layer of powder thermoplast. So this is thermoplast, okay, and then thermoplast will be provided on this bed, which will be at starting, it will be here, and that this thermal print head will heat that layer spacely, not this part, spacely on this part. So heat on this, provide heat, and then that thermoplast will join together, okay, and then again that layer will printer bed will come down, and then you will get that. So these will be in powder form, and then due to melting, this portion, that green portion, the lady idol will be generated. Okay. So again, this is needed for these printers are very much small. On the desktop itself, you can get that printer, not needed to be very big. Okay, so these printers are very small printers, and you can easily get on the desktop. This printer can come. Okay, so selective where to go? Selective laser sintering. This part I have explained. This one, selective laser sintering here. So selective laser sintering was developed and patented by Dr. Carl Duckard and Dr. Joseph Beeman. They are from University of Texas in Austin in mid 80s, especially in something 76 or 77. They have patented this part. Okay, and then then the similar patent, the same similar patent was commercialized. Without commercialized was taken by RF Householder in 79. Okay, little bit difference with the material and all part. So he has also patented this, and but he has never commercialized. RF holder has never commercialized this his process. So we don't know and we don't use this. But this Dr. Carl Duckard and Dr. Joseph Beeman, they have used their patent in commercial form. So nowadays, what we are knowing as selective laser sintering comes from them only. Okay, the same concept is there. So what happening here? It uses how high power laser. So for example, carbon dioxide laser can be used to fuse a small particle of plastic. So plastic and metals can be fused and made hardened and combined with each other, okay, with the help of high power laser, and that laser is direct metal laser sintering. Okay, and ceramic also you can use, glass powder are also used in this and to create 3D shapes. So you can use ceramics, glass powder, plastic, metals, all 4 type of metals just to create 3D objects here. The same concept is there. Okay, so typically SLS machines use pulsed laser. Typically those are just before I told you, I informed you guys that we have nowadays a small printers which comes on desktop itself. So those basically use pulse laser. They are not using high power laser, but in the starting they have used high power lasers. So nowadays we have just pulse laser techniques. Lots of you guys have seen that 3D printing shops, and on that they are using this powder bed fusion process itself. Nothing is special there, so you can read. Okay, now the advantage and disadvantage of that. So advantage is relatively it is inexpensive, very low cost. It will be you can generate your what to say 3D object, and then suitable for visual models and prototypes. So prototypes and models which are going to be visualized, or you can say that small ideals and a small you can say that human based our own face you can create with this. So a small visuals you can create. SHS ability to SHS is one different centering way. Okay. And that is a little bit slow also, relatively slow process is also there. Ability to integrate technology into a small scale office size machines itself. That's why I told you that this comes on desktop printers are also there. So very small size printers are there. So in this technology, so you can use this at your home also to print different kind of 3D objects. And remember, powder are there, so you just need ceramic, glass, plastic, and metal. All you can use on this as a material to create your objects. So large range of material options are there in this. Large range of materials option are there. So you can use metal also, you can use powder, you can use plastic, then you can use glass powder also, you can use ceramic powder also to create that. So that's the benefit of powder bed fusion, but it is really slow process to generate that 3D model. Lack of a structural property in the material, because if you are not using proper material, so the structural property will be not good, and that the product will be not as much strong as you needed. Size limitation is also there. When you are using desktop printers, then definitely the height and that thickness and then width of that model will be compromised. So you can't make big size, very large 3D models and 3D objects. Their size limitation is all, and high power uses because it's huge laser to melt down, and that's why it's needed a high power. And then okay, finishing also depends upon the powder grain size. The powder size, the powder quality is very much needed. the powder quality which you are going to use in to create this here. Their grain size is also very much useful, or you can say very much appropriate when you are creating your finished product 3D object. So that is there. So you should worry about that part also and check that grain size properly, and then you could just provide. So these are advantage and disadvantage of powder bed fusion. Then we have material extrusions. Extrusions basically very much used again. The second one concept which is very much used in 3D printing is fused decomposition modeling. Lots of I think you have heard about this. So FDM method is there. It's also had another name, fused filament fabrications, and most of you have seen this. Okay, that concept is fused filament fabrication, but it comes under fused decomposition modeling. Why? Because this is the trademark term and how they have taken patent. So this is the company Stata Systems, or Stata Sys is there. They have patented this name FDM, fused decomposition modeling, deposition modeling, and that was basically developed by S. Scott Crump in late 1980s. Okay, and was commercialized in nearly 1990 by Stata Systems, and that they have a patent with the name of FDM. That's why it was trademark, and most of the in literature also you will get this part of modeling itself. And basically the concept of FDM is material extrusions. So what is material extrusions? We will see. So when the patent expired in 2002, a large open source development community has started, and they have generated lots of printers and lots of different materials which can be used in this, and filaments are there. So to generate different type of objects. So basically you can say this is the exact process, or this is the exact technology which has given boom to 3D printing. Nowadays, whatever the 3D printing we are seeing around us, this technique has huge role in that. Okay, and that's why after expiring their patent in 2002, large number of open source development community has developed, and then they have created lots of different type of printers, and all of those printers are using just fused decomposition model itself in their base. Okay, so we will see that part, how it's going on. So this is the most common form of 3D printing. So remember and learn this carefully, because I think if you are going to be in domain of 3D printing, definitely you are going to be associated with this technique itself. See, this is the part. Okay, here we have roll, or you can say roll of filament. Okay, in the form of wire. In the study lecture or session itself, I have someone has asked about me filament. So this is filament, and this filament, this especially part is known as filament, and it can be of any object. I mean any material. It can be in plastic form, different type of plastics. It can be of different type of material like aluminum, silver, or you can say copper or something like that. And what will happen? So this have two rollers here. Two rollers will be there. That is going to be servo motor, or you can say any kind of particular motor, and one motor will be here, and this will be the roller point, or that controller, and this complete nozzle has 3 motors. One is here, 1 and 2 is here. So what it will do? This is the complete platform where you have to generate your 3D objects. So what it will do? It will little bit bring this wire, or you can say filament. Then it will run from here to here and melt. It has some heated point, heated or thermal provide heating. At this point, and then that melted filament will drop here. Like this machine will go this side and that side, and then like this, it will start printing this like this. Okay, so you can see lots of videos are there in this working, and I hope most of you guys have seen this type of printer at somewhere or some places. So this one is very much common way and most common 3D printing process is there. It is. So that will generate from here to there, and this complete nozzle will run on this bar itself, and this servo motor will bring down that filament from this point, and that nozzle will drop that liquid, not liquid, I will not say liquid, I will say little bit melted material. That's it. Not it is not going to be liquid. Okay, and that with the help of dryness or the air itself, it will dry, and that complete on normal temperatures will make it hard. So this is the concept, and this can be of thermoplast or something, any material which you need. So this is the complete way I have explained here. So stepper, or you can say servo motors, are typically employed on this extrusion head. So this is the portion which is known as extrusion of the filament here, and that material extrusion, that's why it's known as material extension. And fused decomposition modeling, because it fuse or it provides some heated prior. We are not fusing at after layering, we are fusing it here itself. So fused material will be given here, and somewhere you will known as fused filament also. So filament fabrication or decomposition or deposition modeling is there. So same concept. So it's fused the material prior to drop, and that's why it's known as fused filament or fused deposition. Okay, this is the concept of material extrusions, and some of the most or highly used you can say materials are written here. Acrylonitrile butadiene string, ABS, PLA, HEPS, TPU, nylon, and PEEK, and ceramic and chocolates can be also used. Okay, so paste-like materials can be used here. So most of you guys have seen this type of printers somewhere if you are associated with 3D printing. So definitely. Okay, and what is the advantage? It's cheaper since uses plastic, and more expensive model use different materials to remove support completely. Okay, so water soluble. So in somewhere this tub has itself has water, and on the particular heated water, not too much heated, low heated water, so that this filament can be hardened after dropping. And even cheap 3D printers have enough resolutions for many applications. So very cheap printers you can get in this material extrusion and all. Supports leave mark that requires removing and sanding. Okay, so okay, at this point, the very first layer, when you will remove this from this bed or supports, so that supports is going to get some marks on itself. Okay, so after one printing, you need to clean this part, and this idle also has going to be at the bottom. You have to sand ring, rub in on sand or something to remove the supports and all. So that is one problem. Wrapping limited testing allowed due to thermoplaster material. So wrapping is not there, and limited testing is allowed because thermoplast is material you are going to use in it. Again, another one is directed energy decomposition. So DED, DED. So in this metal, we basically focus on the energy source, okay, which is going to be melt the material, okay, and which are deposited on from a particular nozzle. So um, this is one laser beam. Two different ways are there. Again, I will say this is complete bed, or you can say the platform, upon which one nozzle is going to drop and another nozzle is going to drop another material. So these are material or powder you can drop, and this complete laser will be beamed on those powder or that material to deposit it, or you can say to be hardened. In normal language, you can say to be hardened. Okay, so powder flow will be there, and then this will laser beam will be given to that material to be hardened, and this is one way. Another way is also some time of means what to say, some printers use this one, but both are same, comes under directed heat depositioning. So what you are doing, you are not using in this, you are depositioning heat. The heat will come, okay, the wire feeder or the powder will come, not an issue, but the heat is deposition, means this beam will be given positions. So this nozzle which is providing heat or electron beam or laser beam, that will move from one place to another place. That's why it says energy deposition. Okay, so we are providing energy to be deposition from one place to another place. That's why it is energy deposition. And the previous one, what we are providing material, this is fused material. Fused material is deposition. See, the material itself is depositions from one place to another place. Okay, that's the difference between both of them. Okay. It has laser engineered net shaping, direct metal deposition, electron beam additive manufacturing. These are the some other names: directed light fabrication, 3D laser cladding. These are the another names of DED. You can get in some literatures. You have the name of this. So okay. Typically used on metal parts, the process can be used with polymer and ceramic. Only polymer and ceramics can be used. Okay, and metal also can be used at some point, but not that much. Almost these are the two ways of way, because here we are providing depositioning the energy, that is laser beam, or you can say electron beam will be there. So that's why we are knowing as directed energy deposition. An advantage, ability to control the grain structure to a high degree. Okay, grain structure you can control at a very high degree. So that's the means when you are going to repair your object. So it is very much used in repairing the 3D objects. Okay, and then you will get high quality product also, and functional parts are basically created with that directed heat depositions. Okay, and You need to provide exact speed and quality, okay, to this surface itself and that feeder also. So you have to control both of them and then provide that exact deposition to that beam also, electron beam unit or laser beam unit. And at last you will get high accuracy microstructures can be gained. Okay, high accurate 3D objects and microstructures can be gained in this one. Limited material can be used in this. Limited material can be used in this. This is a problem. Fusion process require more research because how much heat and how much electron beam and where you have to provide that should be properly marked and properly known to prior to build that 3D objects. Okay, and that mainstream positioning should be more into further demands the process into a more mainstream positioning. So we for mainstream positioning of that exact beam location, more research is required to start this process. So that is one drawback. We have seat limitation. Seat limitation is a very easy process. We used to do it at our own home. What? Just take one page and then paste another page wherever you needed. So in Diwali itself, we used to make candela, candela or something lighting lamp-like things with the paper. So what you do, you cut the page and then paste that one page from another page at a particular point, and that laminated that part with the help of some Fevicol or some adhesive like sellotapes or something like that. So that's the ways we use in our day-to-day life, and that's the way seat lessons. I think you guys have seen Sunmica creation, Sunmicas which we used to paste on boards to create the furnitures. Those Sunmicas are not made from wood, you know. They are made from the paper. Paper are added on paper, one paper on another paper, another paper on another layer by layer paper are added, and then they press particular with a particular power for some time, and then the whole paper itself will be converted in the Sunmica, and the upper layer they have providing textures and all. So that is the concept of seat lamination, and which we are going to use here. So see, one layer, another layer. So this is the roll of that material. This is the roll which comes here from here, and then it is showing laser, but I will not say to go with laser. You can use additive, low temperature additive. So plastic films or metal foils can be created with this. So so material is positioned in the place on the cutting bed. This is the bed itself, and the material is bounded in place wherever it is needed over previous layer using the adhesive. So adhesive will be there, and then the complete part will provide on another layer, and then again the cut will mark on that with the help of laser or knife. You can mark the cut. So one page is there, that page is cutted with the help of laser, and then the cutted part has some adhesive, and the another roll of page will come or material will come. Then again the cut will mark on with the help of laser or knife, and then another layer will come of that. So this process will be reversed to provide the complete bounded 3D objects. So that is seat lamination, and its benefits are basically speed, low cost, and easy material handling. Okay, even with the help of paper, think all the prior technology don't have option for paper 3D objects, but in this you can generate even with the paper itself your 3D model or 3D objects. So that's the benefit of seat laminations. And you can say advantage are also there. Okay, because paper and plastic materials requires post processing to achieve desired effects. Limited material can be used, only those can be adhesive to each other, like paper, plastics and all, that only can be used. Those can be cutted with the laser and knife easily, that can be used. So very less materials can be used in this. Okay, so these are the concepts. So all 7 we have studied. So seat laminations, and then directed energy, material extrusions, power bed, binder jetting, and then material jetting, then wet photopolymerizations. So all 7 which are here. So all these 7 techniques we have a process techniques or which we have studied. So now one place I got this concept. So I thought that this will be very useful for you guys. That's why I have given this plot here. So type, which type of technique you are going to use. What are the technologies basically? So inkjet technology, drop on demand or continuous, single or multiple nozzles can be there. Particle decomposition. So these are 2 or 3 techniques are there in inkjet technology. And what are the materials can be used? Hot melt materials, wax, thermoplast, metal alloy, that can be used in this technique. So this chart I got somewhere on net, and I really appreciate who had made this chart. It is very useful. So material extrusion also have fused deposition modeling and fused filament fabrication. Robo casting and MIG welding and 3D printing is also there, or direct ink writing. I have not discussed this one because these are different techniques. Lots of techniques are there. We can't discuss all within 2 hours. And see, 1.5 hours already completed, and we have to learn about software also. So it will take time. So I will support and I will suggest you guys to learn about these techniques also somewhere. But I have provided this some of the part here. So these are the materials and light polymerized techniques. What is that? This is same wet photopolymerization. So another name is light polymerized. So that we have here 3 SLA, stereolithography, and clip we have studied. Direct light processing is also there. So it is also mentioned there in my slides. Then power bed. Power bed has this many techniques. Among that we have studied selective laser sintering, which I have explained also. Or more are there, so you can study. But these are the materials you can use in these techniques. Then laminated techniques are there. The last one is sheet laminations. So LOM is there. So paper, metal foil, and plastic films can be used. Power bed and wire. Wire is one way, but that is also I will not say that it is different from that where it is comes under basically in this one. This used filament itself. So wire is also there, but it's also, you can say that it comes under metal extrusions, or sometimes it comes under power fade. So powder fade and all. So not, this is not apart from these, so I have not used that one. So these many things are there, so you can use and you can learn all these processes. So any doubt in the process, you can ask me right now. Otherwise, I will go with 3D softwares and all. Alok sir?
Yes, sir.
If anyone have doubt in processes, they can ask, or then I will go ahead with software.
Go ahead with software, sir.
Okay, sir. Thank you. Done. So, guys, till now what we have studied about the printers, basically the part which is going to create your 3D objects. So prior to that, yesterday we have studied about the modeling also. So complete 3D printing is, you can say, in two parts. They are in basically in two parts. One is you model the object. Second one is when you create the object. Okay, so creation of objects we have studied, that is 3D printing processes. Now we will go with the model of that objects, how to create and where to create, not how to create. I will not go with that how to create, where to create that models. Okay, so 3D softwares are there, and every 3D prints begins with the 3D model generation, and then that model will be converted in 3D objects. Okay, so that part is we have already discussed just before this in this session itself. Now 3D model generation is there. So I was a little bit confused that what should be taught in this 3D software, because 3D softwares, lots of 3D softwares are there. I have just written 25 here for you guys. They are mostly used in this domain, 3D printing domain, and especially when you will go with Blender, Sketch, SolidWorks, AutoCAD, Maya, 3ds Max, Inventor. Inventor is not that much big one, but these six. And then FreeCAD. FreeCAD is open source, so it is too much used. OpenSCAD is also too much used. Okay, and Modo is too much used. Fusion 360 is also, Max Mixer, Lightwave. These are very much used in this domain. So some of them are I'm going to explain you guys, but what I will suggest, so give me 1 minute. So what I will suggest you guys, so go to this link I have given here. It is Wikipedia page, again I'm saying, and see, here it is given all those 3D modeling softwares and licenses. These are commercial, so these are proprietary softwares. You can go with freemium also. Okay, and here it is completely written. So see, these many softwares are there. Okay, and CAD editors are also there, so that are different. Okay, and computer, and these are also can be used not completely for modeling, but you can use these also. But these are basically comes for 3D modeling software itself. So these many systems are not systems, my mistake. These many softwares are there which you can use. So it's really tough to get expertise on all those softwares. Okay, so I personally use 3D FreeCAD. Okay, that is good, and I personally use Tinkercad to teach my child because it is very funny, and you can say very easy to create 3D models on Tinkercad. So Tinkercad I will explain you somehow, and then FreeCAD is for you can say if you have And if you have to create 3D models, so you can go with FreeCAD also. So I personally use these two, and I will not say each and every work, but they help me a lot to generate any 3D model. So you can go with FreeCAD if you are want to go in this domain, and lots of YouTube tutorials are already given. FreeCAD is completely open source, and it has their FreeCAD itself has you can say YouTube channel. There they used to taught all the how to use FreeCAD and all. So I learned from there itself FreeCAD. And Tindercad I will provide. Whenever it's came in my mind, it's giving me bless on my face, because Tindercad I used to teach my child it about this, and very easy to create 3D objects. So again the same. This is for beginners. If you will go with Tindercad, then a SketchUp is also there. So that is also for beginners. Use this is from Google. A sketch is from Google, so it is very much used and very easy to use this too. Okay. So, and for engineers, these are the proprietary softwares and too much costly. So I will not suggest to purchase individually till you have lots of work on 3D modeling. And these are open source, so you can go with FreeCAD, very much open, and lots of community supported supports is also there in FreeCAD, so you can go with that also. So then I have explained, I have tried my best to explain some of them. Autodesk Maya and Autodesk 3ds Mesh. So these are completely proprietary softwares, and they comes with free trial of 30 days. If you are going in 3D modeling of cartoons and all, so you should go with Maya, because it has good rendering, 3D rendering help in Maya. Okay, so and when you are means large features are there in this, so this is good for 3D design software for beginning 3ds Max. If you are beginner, you can go with this, but if you are expert and you know lots of tools, so you should go with Autodesk Maya. This is also good one. And filmmakers and game developers and visual effects artists basically use Maya and 3ds Max. Both can be used by them. So, and it comes on for Linux, Mac, and Windows also. It's also comes, all of these comes for Linux, Mac, and Windows. So I tried my best. You can download it for on any system or any operating system, so you can go with that. So Blender 3D is there. So it is basically it's also comes for free, but just for 30 days. Okay. They basically brand themselves as open source software, but not completely free. Just for 30 days, you can go with free, and lots of tools are not open for each without purchasing. So I personally don't prefer Blender 3D, and it is open source. They branded themselves as open source, but not completely open source. So when you started and you need some of the tools, to they will ask you to pay, or some tech members or something like that. So franchisee and proprietary software it is, I personally think so. A SketchUp is there. A SketchUp is basically tools which is generally used in Google Earth, and Google has developed a SketchUp. Okay, so architecture landmarks are generally modeled using these tools with Google Earth and all. So it is widely used in real estate sectors. Okay, and to particularly design that part, so a SketchUp is also there. So this is there. So in the net itself you can use. So it's very much open. So like these structures you can create. Okay, like a structures you can create. So it is here. So in designing of buildings and interior designing and also you can create the part and all. So it is also just you have to create this structures and all, and it will be created. And lots of models are already created. So here itself, where it's went fantastic here. I think in this project spectrum. See, so toy shops and all models are already created and given to you guys, so you can use that. No, products, community, SketchUp free. SketchUp free is also there. So SketchUp free is completely free, and Pro and Studio has an enterprise has some amount you have to pay. Okay. So then we have Modo software. It is basically used in designing and VFX industry, and very small micro operations can be generated in this. And when you are going for a small parts to be replicate, or you can say the repeated generation, so Modo has good support for that. You just have to copy and paste part, and that will be repeated generated. You just have to looping them. You can loop them. So, and again, I'm saying that is completely proprietary software, so it is not free. It is just free for 30 days itself. So you can, and it has a powerful 3D rendering software. Remember, so it is very powerful rendering software, 3D rendering, because 3D, when you will render 3D objects, it takes too much time and too much processing power also. So you need very good rendering software. So Modo has that facility, and that's why lots of developer has moved from CAD and Blender to Modo software itself. It was not that much old software, but very much very fastly it has gained popularity among developers and all. Then we have AutoCAD. Then we have a Sketchfab. A Sketchfab is also there. So a Sketchfab platform is basically for manage 3D assets and all. So it's a website. Okay, and you can buy and sell your 3D models also. See, let me show you guys. So you can join for free and see plans also. So it is a leading platforms for 3D and AR on web. And then what they are doing, so you can buy and sell also. So you can buy and sell models also here. Let's open. Okay, see. So animated and also these many domains are there. You can buy for. See this type of 3 models you can create and purchase. Sell also, so you can create your own model and you can sell there on Sketchfab. That's why I have mentioned it. So where you can here itself it's rendering and showing you the complete 3D view, and you can generate and you can create. So you can see this architecture and furnitures also can be created and sold out here. Complete asset plannings and all can be sold out. So you can buy and you can create your own 3D. AutoCAD has completely commercial. It's very much used. I think we used to teach in colleges also AutoCAD. We have software, and civil and mechanical guys can easily relate themselves with AutoCAD. So in universities and colleges, they used to teach on AutoCAD itself, and it is very old. So 1982, and then till now, it has complete, you can say, hold on the market itself. Then we have ArchiCAD. ArchiCAD is also there, and Tinkercad. Tinkercad. Let me show you guys Tinkercad. I personally admire it. It already hit my history, so very childish look it has, and very much useful. So you can teach your means see, you can use to teach your child on this. So it is completely free, so you can go with that. And let me show you. It has too much community support. It has, so okay. Where it is? Okay, yeah, here. Let me close this. So see, very childish things you can create, and you can ask your child to create that, and lots of things are there. So see, these are all just childish models and all. So your child and you will also enjoy. I personally, that's why I admire this Tinkercad. And it is completely kid safe, and also so classrooms and all those things are there. So let me go on that part where it is. Learn, teach, gallery. See, so you can create these many, not these many, lots of things are there. So see here. Okay. So 3D you can create here views and all. So I personally admire this. I'm not saying that you can't create professional models also, but you can easily create professional models on Tinkercad. But most of the community has started created it especially for child and kids. So this here, you can take it on your laptop also and desktop also, and then you can create. So Tinkercad, and then ArchiCAD is also there. So it is basically for architects, because this is ArchitectCAD. So it supports basically architectural 3D software. So architectures can use this and mostly use that this ArchiCAD and also. Then we have SolidWorks. SolidWorks has computer-aided engineering and computer-aided design, both part in itself in one place. Okay, and it supports on Microsoft Windows, and they have most of the millions of designers and engineers are there, and they have used. In 2013 itself, it has over 165,000 in companies are using this. So it is mostly used and very much ArchiCAD, and you can say AutoCAD, and then Maya. These are basically the three biggest, you can say the bigger dominators in this 3D printing and all. So V-Ray render is also there. So one minute. V-Ray render basically used for 3D rendering, 3D object or 3D model rendering. It is mainly developed by for render itself, and this has lots of plugins and which you can use in Google SketchUp also, Cinema 4D, 3D Max also, Autodesk, and lots of softwares can be not this can be plugged in lots of softwares. Okay, and that's why it's a versatile software, and you should try out, but only for 30 days you have free options. You should purchase it after that, and it's basically they have developed it for rendering realistic rendering, and also this is developed basically for rendering 3D model rendering. Okay, then we have mental ray. This is also one you can say rendering software itself. So these two are basically rendering softwares, 3D model rendering, and it is very much close for V-Ray. Then Octoprint. Octoprint is also free and open source. So let me show you guys Octoprint. Octoprint is also you can say open source, and it also has open source 3D printer. It is basically, and what is this? Okay, so it is open source. That's why they are asking for funds and all, so to develop it more, and it is also 100% completely open source. So like FreeCAD, it is open source, and I have not used that one, this one that much, but you can say I never used this one. But I got knowledge about this also on net, that it is free. So okay, so you can easily download and start, because it has full control of the printer. That's the best part I got on knowledge from that internet itself. It has even you can control the temperature and all the things, temperatures, and then nozzle and all of the printer. So it has the benefit of that. So it is good one. So you can go with that, and then thank you. Thanks. That's complete from my side.
Thank you, Ashish sir.
Thank you, sir.
For
If anyone have doubt or any question, so they can ask.
Any query and any question related to sessions, these related sessions?
Okay, sir. Thank you, sir. Thanks a lot, sir.
Okay, thank you, sir. Very well. Thank you, sir.
I will mail you this slide so that you can drop it to each one is the participants, and they can make use of that.
Okay, sir. Okay, thank you, sir. Okay, thank you, participants. All the participants. Over the next session, it will be 12:15 p.m. with Dr. Saurabh Bhaskar. Thank you.